All right, this is the first video in the Physics 1 review for Physics 2. So we've got three main concepts from Physics 1 that we want to continue to use in Physics 2, and I wanted to give us a quick reminder of those concepts. So the first one is constant acceleration, and in particular, constant acceleration in a straight line. So first, we need to remind ourselves, what is acceleration? And in physics, this is maybe a little bit different than in the English language, where we think of acceleration as just speeding up. Yes, speeding up is acceleration, but so is slowing down, and so is changing directions. So if something is not accelerating, that means it's not speeding up, not slowing down, and not changing directions. So an object that's not accelerating would be moving in a straight line at constant speed, or just not moving. Anytime your speed changes, you speed up or slow down, or the direction of your motion changes, you turn left, right, or whatever, you are accelerating. So what are the units of acceleration? The units of acceleration are meters per second squared. And this makes sense if we're talking about speeding up or slowing down. So if you are speeding up and you are gaining 5 meters per second each second, that means you gain 5 meters per second in the first second, and then you gain another 5 in the second second, and then you gain another 5 in the third second. So for example, you might have your speed might be 3 meters per second to begin with, and then after 1 second, you'll be up to 8 meters per second, and in the next second, you'll be up to 13 meters per second, and then the next second, you'll be up to 18 meters per second. You can see that you are gaining 5 each second, so that would be an acceleration of 5 meters per second squared. You could also have an acceleration of negative 3 meters per second, or negative 3 meters per second squared. If our initial velocity was, let's say, 7 meters per second, then after 1 second, we would slow down to 4 meters per second. After the next second, we would slow down to 1 meter per second. And then if we continued to have constant acceleration, after one more second, our speed would have to be negative 2 meters per second. Which means we're moving in the opposite direction. We're moving backwards at 2 meters per second. And then if we continue to have constant acceleration, our next velocity would be negative 5 meters per second. Because again, we're losing 3 each second. And that means we're actually moving faster. And this is important because from 7 meters per second down to 1 meter per second, we were slowing down with our negative acceleration. But from negative 2 meters per second to negative 5 meters per second, we were actually speeding up. And we still had a negative acceleration. That negative acceleration was giving us a faster and faster negative velocity. Okay, so the units are meters per second squared, and it tells us how much speed we gain each second. So if we have an acceleration of 5 meters per second squared, that means the speed is increasing by 5 each second. If we have an acceleration of negative 3 meters per second squared, that means our velocity is decreasing by 3 meters per second each second. Okay, so constant acceleration along a straight line is important because it means that we can get rid of the changing directions part. So if we have constant acceleration along a straight line, this means we are absolutely either speeding up or slowing down. And we could actually be doing both. For example, if I have an object that starts with a velocity of 20 meters per second up and has an acceleration of negative 10, after the first second, it will slow down to 10 meters per second, and in the next second it will slow down to 0 meters per second. But in the next second, it will speed up to negative 10 meters per second. And in the second after that, it'll speed up to negative 20 meters per second. So it slows down first and then it speeds up. But that's still constant acceleration because the acceleration was negative 10 meters per second squared. The acceleration was negative 10 meters per second each second for the whole trip. Okay, so how do we solve problems with constant acceleration? To solve a problem with constant acceleration, what we need to know, well, there are 5 quantities that we are interested in. We would like to know the displacement of the object, and that is how far has it moved during the constant acceleration. So if we have a starting point and we have an ending point, the displacement is just the distance between the starting point and the ending point. And if our positive direction is forward, then a positive displacement means that we have moved a distance forward. If we had a negative displacement, it would mean we moved a distance backward. The other things we need to know are our initial velocity. I do not like that fat pen. How fast we were going at the beginning of the acceleration, our final velocity, how fast we were going at the end of the acceleration, and the time. So of those 5 quantities, if we know 3 of them, we can find the other 2. So as long as we know 3 of these 5 quantities, we can always find the other 2. And the idea is, displacement is how far we've moved. The initial velocity is how fast we're moving at the beginning. The final velocity is how fast we're moving at the end. And the acceleration is how quickly we're speeding up or slowing down. And remember, all of these things could be positive or negative. If you have a positive displacement, that means you have moved forward. A negative displacement means you've moved backwards. If your initial velocity is positive, that means you start out moving in the forward direction. If your final velocity is positive, that means you end up moving in the forward direction. Acceleration can also be positive or negative. And again, this refers to the direction of the acceleration. If the acceleration is positive, that means it points in the positive direction. If the acceleration is negative, that means it points in the opposite of the positive direction. So which way does acceleration point? If you are speeding up, then your acceleration is the same as your velocity. If you're slowing down, that means your acceleration is the opposite direction as the velocity. Okay, and time is always going to be positive because we start at time equals 0 and we finish sometime later, so we're always going to have positive times. So these are the 5 quantities that we're interested in, and in any problem, we should be able to determine 3 out of those 5 from the problem, and then we'll use math to determine the other 2. And if we have a constant acceleration problem, there are 4 equations we can use. One is that the displacement is equal to the initial velocity times time plus 1/2 acceleration times time squared. Another one says that the displacement is equal to 1/2 of the initial velocity plus the final velocity times time. Another equation says that the final velocity is equal to the initial velocity plus acceleration times time. And the last equation says that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. Now, there are a couple of things you can do to help you remember these equations. And I do want to refer you back to Physics 1 to remember some of these. But if we have a velocity versus time graph, and we have an initial velocity and a final velocity, and we have constant acceleration, we're going to have a straight line between the initial velocity and the final velocity. So this graph can actually help us remember 3 of these 4 equations. So the first equation says that the final velocity is equal to initial velocity plus acceleration times time. And here, that is basically the equation of this line. Because velocity at any given moment is equal to the initial velocity plus acceleration times time, and acceleration is the slope of this line. So this is just y equals mx plus b, or y equals b plus mx, where x is our time, acceleration is the slope of the line, and v0 is the intercept of the line. So we can think of this equation as just like the straight line, y equals mx plus b, the straight line of that graph. For displacement, the displacement is the area made by filling in this trapezoid, or whatever shape that is. So if we can figure out the area of that shape, we can find the displacement. And this equation looks at that area and says, that area can be thought of as a rectangle plus a triangle. And the rectangle has a height of v0 and a width of t, so v0 times t, and the triangle has a width of t and a height of at, and the formula for the area of a triangle is 1/2 base times height. So that equation is just finding the area under this curve, a rectangle plus a triangle. The second equation says, okay, let's find a point halfway between the initial velocity and the final velocity. Okay, we'll call that our average velocity. 1/2 the initial velocity plus the final velocity is the average velocity. And if we multiply that by time, we get a rectangle that happens to have the exact same area as the trapezoid that we were trying to find. Why is it the exact same area? Because it's missing a piece over here, but it's got a piece over here the exact same size that it has extra, and so the area of that rectangle is the exact same as the area of the trapezoid. So this is also just a way to find the area under the curve. So that graph can actually explain all 3 of those equations, and then we're just left with this last one, which we can't explain from the graph, but we can get some help by looking at the units. Velocity squared has units of meters squared per second squared. Velocity squared here has units of meters squared per second squared. And acceleration is meters per second squared times distance, which is meters. So all 3 pieces have units of meters squared per second squared, and that can help you remember that equation if you are like, oh, I want that v squared equation. How does it go again? And you can remember that you're going to need acceleration times distance, because then you have the correct units. All right, finally, let's do a quick example. And I do not have one already made up, so I just have to make one up off the fly. So let's say that we have a ball is thrown upward with a speed of 8.00 meters per second from an initial height of 2.00 meters. Where is the ball 3 seconds later? And also, how fast is it going? And instead of 3 seconds later, let's see. Let's see. I'm going to change this problem a little bit and give this an initial velocity of 16 meters per second. And this is supposed to be a comma. I hope that doesn't look like anything else. Okay, ball's thrown upward with a speed of 16 meters per second from an initial height of 2 meters above the ground. And I'm going to change that again to 5 meters above the ground. Where is the ball going? Where is the ball 3 seconds later, and how fast is it going? Okay, so remember I said, all right, well, first thing I'd like to do is sort of draw a picture. So I know that the ball starts 5 meters off the ground, and it starts out moving upward. And I can imagine that this ball is going to move up, and then maybe it's going to fall back down, and by the time 3 seconds have passed, it might be moving downward. Maybe. That's just sort of a guess of what I think the motion might look like. Okay, and so how do we solve this? Remember, we have displacement, initial velocity, final velocity, acceleration, and time are our 5 variables. And as long as we know 3 of them, we should be able to solve the rest of the problem. So displacement is how far are we from where we started. If the displacement was +3, that means the ball would end up 3 meters above where it started. If the displacement was -2, it means the ball would end up 2 meters below where it started, because I'm going to pick the positive direction to be up. So anything that's positive means up, anything that's negative means down. But we don't know the displacement from the problem. That's not one of the things we were given. But the initial velocity we were given, that should be 16 meters per second. And I want to know, is that a positive initial velocity or is it a negative initial velocity? And it's positive because the initial velocity points up. Okay, the final velocity is not given in the problem. The acceleration doesn't appear to be given in the problem. The time is given in the problem. That was 3.00 seconds. So it looks like only 2 things were given in the problem, so right away this maybe sounds like a problem that we can't solve. However, there is one thing that we know from physics, and that is if we ignore air resistance, when things are falling through the air, the acceleration is going to be negative 9.81 meters per second squared. And that negative means that the acceleration points downward. So my acceleration is negative 9.81 meters per second squared. And now I've got 3 out of the 5, and I can go ahead and solve the problem. So my displacement is equal to V0 t plus 1/2 a t squared. So if I plug those numbers into my calculator, I get V0, which was 16, times 3 plus 0.5 times the acceleration, which is negative 9.81 times 3 squared, and so I get a displacement of 3.855 meters. Now, what does that mean? The displacement is how far we are from where we started. So if the displacement is positive 3.855 meters, then that means I drew my picture wrong, because the ball's going to end up above where it started. Because the displacement is positive. If the displacement had been negative, it would end up below where it started. Okay, so actually I think at the end, I'm going to say it ends with a height of 3.855 meters above where it started. It started 5 meters above the ground, so it has a height of 8.855 meters. I'm still interested to know its final velocity. The final velocity I can use equal to initial velocity plus acceleration times time. So the initial velocity was 16 plus negative 9.81 times 3 seconds gives me a final velocity of negative 13.43 meters per second. Means it's going down. So this means the ball has gone up to its peak and then started to come back down. So the final velocity is negative 13.43 meters per second. So at the end, I will say that the speed is 13.43 meters per second down. All right, last thing I want to do is check my significant digits. It looks like there are 3, 3, and 4 significant digits in the problem, so I'm going to use 3 significant digits in my answer. So that means that I should round this to 3 significant digits, 8.85 meters and 13.4 meters per second down. All right, and that is a quick review of constant acceleration, and please feel free to watch my videos from Physics 1 if you want more.